Yo, what's up, guys? Shit. Okay. Welcome back. Another video. We're doing a little late night video here. It's about 9 p.m. Had a super long day, man. Coaching, playing tennis and stuff. So, I was at the facility for like 8 hours today, so I'm kind of exhausted. It's been a really long day. To be honest, I really, really did not want to record this video, but yeah, I felt like I just had to. So, it's gonna be a very, very short video, probably less than half an hour long. Probably gonna take a look at one, maybe two problems. So let's get straight into it. Let's take a look at Pokemon sound of the day. This is episode 75. We got a Graveler, the evolution of Geodude. Graveler sound. Let's take a look. Da 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 da. I don't know. That's too high. It's like da 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 da. Well, there's our sound. Take a look at some of our problems. Got a fire hot chocolate with us. Number of ways to arrive at a destination has got crazy low acceptance rate. It's a graph traversal problem. I'm definitely very excited to get to some graph problems later in the future, though. But yeah. All right. We'll take a look at our powerful study plan. Let's pick a problem from here. Maximum distance between node and ancestor. See, I go through this, man. I didn't even know, like, flatten binary tree to linked list. I'm sure we probably looked at this one before, but so we're given two nodes, P is equal. The lowest common ancestor. I'm trying to think what would be the best way to purchase from. Why do they look like this here? Root tree node, P tree node, Q tree node. I'm trying to think here. I'm thinking we start at the top, right? We have our root node. We keep searching because it is a binary search tree. Everything is in order, so we do well. We have 2 and 8. Why is it not my default browser? What is going on here? $235 lowest common. Told me the iterative approach is the best. Let's take a look at this. So while root, we want to check, well, if P is greater than root, and it should be probably P dot val, right? P dot val is greater than root dot val. And greater than root dot val. Then the LCA must be in the right subtree. So then we do, well, root is equal to root dot right. Else if P dot val is less than root dot val. Whoops. And Q dot val is less than root dot val. we can do root is equal to root dot left, else pink different sides or one of them matched. I think we just return the root. Bro. No way it was that easy, bro. That is crazy. Wow. So what we do here, we have if it's null, we return none. If root is equal to p or root is equal to q, we return the root. Mm. tied here, bro. Does it go to 6? We go. Trying to figure out this recursion, man. I'm getting confused here. I think this stuff is confusing me, but It's a little confusing reading this, bro. Like I don't understand how this returns 2. Like, I can't seem to understand, right? We loop through, we get to 6, right? We go, okay, none of this stuff really applies. None of this is equal, right? Talk about this test case here, right? We call left, okay? So we go to 2, we realize, okay, root is equal to p, we return the root, we come back to our original call, then we execute right? Our right is equal to 8, right? If not root, return none. That's not true. If p is equal to, that's not true. So then we must call left again, right? Like, how does this write? I don't understand how it's not, how it returns none. That's what I don't get. And this shit is not helping me at all understand why. Okay. Okay, I think we are going through. So we go to 8, we realize none of this, we call left. We call left is equal to 7, right? Then it finally gets to, well, over here, if not root, returns none. Then this returns none. It returns none up the stack, I think. It returns none up the stack. Okay. I understand. When I was prompting GPT, I was like, where is this returning? It like wasn't telling me it was going through. And I was like, well, why isn't it going through? It would go through. We keep calling it. And it's like, bro, this shit is terrible at explaining. Like, anyway, I think we understand. I'm going to go to another problem. What a stupid explanation. Like, seriously. We're going to take a look at probably one more problem. I mean, we spent like, what, half an hour on that problem. So let's take a look. Let's, Jeez, man, I cannot believe we did pretty much all these problems. That's crazy. I think we'll leave one of these for another day. Let's do a binary tree problem. Do one more binary tree problem. We'll call it. Oh, get rid of this. When did we do this one? March 14th. Oh, geez, that was like 8 days ago. Maximum depth of binary tree. Given the root of binary tree, return its maximum depth. The binary tree's maximum depth is the number of nodes along the longest path from the root down to the farthest leaf node. The longest path. So we return. One, two, three. I feel like this would a little bit be like BFS, no? From collections call it DQ. All right. We create a DQ is equal to can we pass in our depth maybe? I think our depth is 1. While Q for I in range. Let's calculate our length. Our length is equal to the length of Q for I in range. We want to do node depth equal to q dot pop. Guess if node dot left, we want to append q dot. This should be pop left. Q dot append node dot left depth plus equal to 1. If node dot right q dot append node dot left. Actually, node dot right depth plus or equal to 1. We can return our depth. Let's return max depth 0. Max depth is equal to max depth, and then we pass in something else. Our depth. I think this should work. How about syntax? I'm sorry, is it? I think it should be depth plus 1. Can't unpack non-iterable. What? Okay, I think that should work. Has no attribute left. Nice. We solved it with BFS. I realized technically that I think this was a DFS problem. So, should we solve it with DFS? Yeah, I'm gonna quickly solve it with DFS because why not? Let's create a stack. I think we're gonna do it the same way, but instead, keep track of the depth by itself. While stack stack node depth equal to stacked up hop. Check if node dot left, if node dot left stack dot append node dot left depth +1, node dot right stack dot append node dot right depth +1, max depth equal to max depth. Then we pass in our actual depth, right? Calculate max depth. Alright, we want to return our max depth. Not root, we just return 0. Nice. That is faster. Should we solve it using recursion now? The triple whammy, dude. The triple whammy. Let's try. How we want to solve it using recursion def. DFS. We want to pass in our node, probably our depth. Alright. Probably outside here, we want to define like a max depth is equal to 0. We want to call DFS. Our root depth is 1. If not node, we just return. Otherwise, we want to calculate our max depth. Max depth is equal to max depth. We actually check our depth, right? Check, well, if node dot left. We do DFS. Node dot left. We do depth +1. Node dot right. Node dot right is equal to DFS. Node dot right. Depth +1. We want to return our max depth. Will this work, dude? I don't know. Can I actually look over depth max? Blah. Blah. Can I make it non-local? Local max depth. No way that worked, bro. How can I do this without non-local? Depth of the current node is a maximum of the left and right depths +1. A cool way to think about it. If not node, we return 0. We don't keep track of a max. We don't keep track of the depth. Get rid of this. Right. Can just return our root. Get rid of this. We can just return DFS root. Get rid of that. Get rid of that. Push this up. Right. Cat's meowing. Get rid of no dot left, no dot right. Right. The max of no dot left, no dot right, and you add 1 for the current. Interesting. Interesting. All right, we're gonna call it there. 45 minutes. I appreciate you guys watching. We'll be back at it with another video tomorrow. See you guys later.